further ado, thank you, Serena. I'll hand over to you.
Hi, good morning, everyone. Morning. Everyone's so friendly. I'm Serena, and I am a product designer professionally. And I'm interested in the intersection between security and humans. And I'm here because there's a pervasive myth that exists in our industry. And it's the myth that usability and security are mutually exclusive. The thought to make something more secure means that you inherently have to make it harder to use, or conversely, making something really nice and easy to use inherently makes it less secure. And by the end of the talk, I hope to convince you all that this is not true, and in fact, the opposite is true. Good user experience design and good security cannot exist without each other. And when you think about it, it makes sense. Like, a secure system is reliable, it's controllable, and hence it has to be usable. And a usable system reduces confusion, leading to better security outcomes. Now, I'm sure everyone in this room is nice and friendly, and we all agree that everyone deserves to be secure without having to be experts. But I'm not sure if our current way of working really encourages that. Because if everyone deserves to be secure without being experts, then we need to stop expecting people to become security experts, which is kind of what we do. Now, I know this might be hard to hear in a room full of people who are interested in security, but no one cares about security. They care about it in theory, but at any given time, that's not the main thing anyone's thinking about. Given a choice between dancing pigs and security, the user will pick dancing pigs every time, classic. Now, this quote is from '99, so the memes are a bit outdated, but the ideas stay the same. We expect people to invest all their time into security, and when they don't, naturally, we shame them. And great movie. In security, there is a pervasive culture of shame. Now, I'll be the first to admit that I've totally participated in this as well, whether it be laughing at people for putting their credit cards on the internet, or laughing at people getting their passwords scammed on IRC, telling people to use something completely unusable, and then belittling them when they can't figure out how to do it. So it's really understandable for us to lament that we live in a world full of idiots, but it's unhelpful. And we all here work in and around tech, so for us, it's downright lazy. It's laziness on our part, pure and simple. People wanted to complete a task, and we have failed to provide them with a secure and easy way to do that. And that's on us as people making the software, not on them. And by the way, who here, like, when a command fails in terminal, you just type sudo the same command without even thinking? Like, we're all just people who want to get things done. So it's okay that no one cares about security, because they shouldn't have to. We should. It's our job to build accessible, performant, and secure code for everyone. Whether we're security experts, developers, or a designer, it doesn't matter. It's our job. And in design, my area, the focus is on the end user experience. So instead of overwhelming people with complex technical instruction, we can build security that's intuitive, that's friendly, and that people will actually use. You can think of design thinking as another tool in your problem-solving toolkit. So, after today, when you get in an inevitable tug-of-war between usability or security, I'd like you to step back and consider 4 things. These are 4 things that designers have to consider every day, but it'll get lost in the complex technicalities of your everyday job. The first is paths of least resistance. Now in security, I'm sure we all know, we're used to putting up a lot of walls. Like, did you want to do this thing? Have you considered not doing the thing? Oh, you needed to open up a program to do your job. Have you considered getting a new job? Computers were just a mistake, and let's just turn off the internet. And to be fair, this is a symptom of security concerns being tacked on right at the end of the development cycle. But if design and security start working together, we can stop thinking about putting up walls and start thinking about carving rivers. We can direct people in such a way so that the path of least resistance matches the path of most security. And in many ways, we're already doing this. If you considered the secure by default principle, this is just the trivial path of least resistance. What happens if you don't do anything? And that can be simple as defaulting to the least dangerous option in a dialogue, or if you want a physical analogy, think of those blenders with motors that don't turn on unless the lid is on. Like, you can't screw that up. When it comes to crafting paths, making security actions a normal part of the process is what we want to do. So we don't want to give extra homework to people, we just want to make security the natural thing. So let's say you need someone's phone number to verify their account. Don't count on them going through your settings menu, just ask for them straight up when they sign up. Make it a natural part of whatever process they're doing. So if I'm already prepared to fill out a really long form, then asking me for more details is fine. But if I'm coming to your app, or to your organization even, with a specific task in mind, I'm not going to go through a setup process no matter how much I care about security. Group similar tasks together. So if I'm here to check a status or get something done, I'm probably not going to worry about setup stuff. If I'm here for setup stuff, you can front load all of it all at once. Because it's natural for humans to be economical with our physical and mental resources. Security isn't the thing that people are usually thinking about. They're thinking about their task at hand. Therefore, our primary consideration as people who make the software is to keep the end user's goals and our security goals aligned with each other. When these goals become misaligned, people will start subverting your security measures, both unintentionally and sometimes even intentionally. Take security warnings, for example. Now, to be fair, these have gotten a lot better over the years, but I'm sure we all know someone who comes up against the screen and just breezes through without a worry in the world. Why? Because figuring out whether to trust a connection or not is not their current goal. So what happens when someone sees this warning? Oh, no, connection isn't private. Dang, but I want to know what pileofcats.exe is. But that's okay, that's all right, because I'm an adult and I know how to internet, and I know all I have to do is click here and proceed anyway. Why doesn't friction work here? I should clarify that when I talk about paths of least resistance, I'm actually talking about paths of perceived least resistance. If dismissing 10 security warnings in a row is how I learn to get a task done, I'm going to do it every time. And after a while, I'm not even going to see the warnings at all. Each false alarm reduces the credibility of a warning system. Now, there's been heaps of studies done about this, including this interesting one by Anderson et al. They watched some university students look at repeated warning dialogues in an fMRI machine. And what they found is that after just two exposures, they did less visual processing, which isn't to say that they saw it and thought, I don't care, peace out. They stopped seeing the warning dialogues. You might have heard of banner blindness in the 90s. This is the exact same thing. And this is bad. And if you think that users ignoring your security warnings is bad, think about your colleagues and your employees doing it too. Shadow IT is the process that employees actually take, instead of the one being sanctioned by security because it's too hard. When security processes are presented as something that obstructs rather than something that enables you, people will find another path. Here's a classic example. How many of you have worked at a company with a password rotation policy? Me. You know what happens, right? Password rotation policies mean short passwords, reuse of passwords, stick it on your computer passwords. Password rotation doesn't work, and we know this. Because here's the thing, if you keep putting up obstacle courses inside your product, your app, or your organization, as it turns out, people just get really good at obstacle courses. So how do we fix this? Well, first of all, we can use security tools for security concerns. Sounds straightforward, but if I had a penny every time got around their company firewall just to listen to Spotify, I'd have many pennies. If your employees are spending all their time on YouTube instead of working, that's a management problem, not a security problem. And people are reasonable. If they see that security software is being used to block not security threats, they'll just get really good at subverting your security. When you want to make good paths, don't make people think. Again, build rivers, not walls. Make the secure path the easiest path. A really good example of this is a thing called BeyondCorp at Google. I'm sure quite a few people must have heard of this by now, but for people who aren't aware, it's a security model developed in response to an APT in like 2008, 2009. And a crude way of explaining it is that instead of having a traditional boundary of on-network and off-network, they just put their entire network on the internet and remove that security perimeter completely. Which is kind of cool, because when you put all of your stuff on the internet, you have to start doing the real work of making sure your authentication systems are reliable, you've got good models for what all the different roles in your organization should and shouldn't have access to. And you can start to really go a bit deeper in mapping out what's usual behavior and what's unusual behavior. But what made this so successful wasn't just the ingenuity of the model. They had a really strong focus on user experience when it came to implementation. They designed their tools so that the user-facing components were clear and easy to use. And for the vast majority of people, it's completely invisible. And that's how security should be. It should be easy, reliable, and invisible, with your goals aligned with the end user's goals, making rivers, not walls. Okay, cool. So how do we do that? Well, if we want to align our goals with the end user's goals, we need to know their intent. So, what is everyone's intent? Having a clear view of everyone's goals will set the foundations for how you approach problems later on. Again, sounds like common sense, but we forget about intent all the time. It's where the tension between usability and security occurs in the first place. And it's easy to forget about intent because trying to infer it is really difficult. So instead of thinking about what everyone's goals are, we kind of fall back on common patterns like, hey, I'm a designer and usability is my responsibility, so I need to make everything easy. Or, hello, I am a security expert and security is my responsibility, so I'm going to lock everything down. The next time you catch yourself falling back on these common patterns, remember this. It's not my job to make everything easy. It's not even your job to make everything secure. So what's our jobs again? Our jobs are to make specific actions that a specific user wants to take at a specific time in a specific place. Easy. Everything else we can lock down. Therefore, if we want to tighten security without sacrificing usability, it requires us to know the end user's intent. This is easier said than done, of course, but next time you come across a problem where you feel like you need to sacrifice one or the other, instead of falling back on your usual patterns, step back and ask yourself, who are they? Do we not know? Does our authentication system need to be more robust, more trustworthy? Are people sharing logins, for example? Is that a problem we need to solve? What time is it? Where are they? Do we need better behavior modeling around their time and rough location? Are these things too easily spoofed? Is the data not very good? What are the usual things we'd expect someone in their role to do? What's unusual? And what's the bare minimum of personal data that we can use to infer these things? You really don't need a lot. For example, if I'm going overseas, I'm going to tell my bank that I'm going to be overseas for some time, because they have a behavioral model that says it's unlikely for someone to make a payment outside of the country that they're in. Sure. You don't need precise data. Even simple things like country of origin or even time of day can suffice, and they can inform you on what this person's intent is. But at the end of the day, bring it all back to the goals. Okay, so let's say we have a better idea of the user intent. How do we communicate to that intent is the next thing. I'm going to get some water. Can I just take this? Sweet. Free water is life. Okay, so about communication. I would like to challenge you all to think about communication a little bit differently. It's not just like a fleshy, mushy, human-based I/O that's a bit of a drag to deal with sometimes. I want you to start thinking about communication, and specifically miscommunication, as a human security vulnerability. Because this is the thing that social engineers exploit, areas of ambiguity. So here's a question. For the project that you're working on right now, what are you unintentionally miscommunicating? A really good example of this is the classic secure green lock. We've all seen it. Thankfully, this is a bug that's been fixed, but it's a really good example of how just an innocent miscommunication can turn out to be a serious bug. And why is this a bug? Well, let me ask you, what does the secure lock mean? Shout it out. Get some audience participation. Yes, and that means that it's... Yes. Yeah, so we... No. Well, that's the thing. So we kind of roughly know that the screen secure lock means that my communications to whatever the domain name is encrypted, and also the domain name is who they say to are, according to some mysterious wizard-robed cartel. Yeah, essentially, yeah. Oh my gosh. That's true. Okay, so cool, we kind of roughly know what it means, working in tech, awesome. What do you reckon just the average person who's using a browser might think this means? They think it means it's secure, because it says secure. That's, yeah. But we know that's not necessarily true, so this is a miscommunication. And whenever there's a miscommunication, there is a human security vulnerability. So let's say I got bored one night and I felt like doing some crime. And I thought, just go on and register myself a legit looking domain name. Cool, 20 bucks, awesome. And then get me a free SSL certificate. Thanks, let's encrypt, you're the best. And with my elite hacksaw skills in HTML and CSS, the best markup, I could create a pretty convincing phishing website that the browser explicitly labeled as secure. That was just some nice screenshot work. But phishers do this actually all the time. And it works. It works really, really well, which is a bug. It's a human security vulnerability. And one that's on its way to being fixed, thankfully. But the point stands. Do your end users know what you're trying to communicate? What is their mental model of what's going on compared to yours? Which brings us to our last and final consideration, mental model matching. This is the most important consideration of all, because our end users' mental models are what define whether our systems are secure or not. Not your tech stack, not your architecture, but their expectations. That's what defines whether our systems are secure. Think about it. Like, a man-in-the-middle attack isn't inherently insecure. Telephone is a string of man-in-the-middle attacks, but it's not a security incident. It's a pointless children's game that tells you which one of your friends is a lying poop. No, man-in-the-middle attacks for us, in our case, is usually bad because our users expect their data to only be available to expected parties, and the party in the middle is unexpected. A system is secure from a given user's perspective if the set of things that everyone can do are bounded by what they think everything can do. Therefore, if we want to design secure systems, it means that we have to understand the end user's mental model, how they expect things to work in our app, not necessarily how things actually work. And we can do this in one of two ways, and I think we should use a combination. So first we can find out more about what they think, their model. And the best way to understand someone's mental model is to practice observing without judgment, someone using the system that you're building. Now, depending on what company you work in, you might have designers and UX research people, and they might run some user interviews or customer sessions. Try and go along to those. Go up to them, ask. They will be super, super happy to let you observe, or even just listening to transcripts is really, really helpful. At work, we've had a lot of developers and just generally anyone on the team come in and observe these interviews and these sessions, and they've been amazing. Every single person, every single interview has walked out with at least one foundational assumption just completely destroyed. It's really easy when we work in tech to kind of think we understand how people use tech. So going along to these sessions keeps us honest. If you don't have access to these sessions, just observing your friends and family who don't work in tech use the technology around them is a really good way to practice getting yourself into other people's shoes and to practice understanding why they might do the things they do. Yes. Spoiler alert, okay. And of course, we can try and infer their intent through things like context. The other thing we can do is we can try and influence their mental model, try and change their mental model so that it better matches what's actually happening. And a good thing to remember is that whenever we make something, we teach. And whenever someone uses something that we make, they learn. Often the path of least resistance becomes the default way that people do things. So here's another question for you. How are you already influencing your users' mental models? For the longest time, and I don't think they do this anymore, But if you've ever used like an Apple product, you'll remember that randomly an iTunes password prompt would come up, just randomly, and you're like, what, why, okay, fine. Which is fine, I guess. They need to verify that I am who I say I am for whatever process is running on in the background, sure, cool. But here's another thing to consider. Every time this pop-up happens, they're training you, and they're training everyone who sees it to just blindly type their password in whenever they see this pop-up. So here's some screenshots. On the left is the iOS one, and on the right is a phishing attack. Pixel by pixel, they're exactly the same. So what are we teaching people? Are we teaching people that warnings are fine and you just breeze through them? Are we teaching people that security is an obstruction rather than something that helps you? Try and understand your end users' mental models. I have a thing. Is it secure? That's a meaningless question without first specifying who it's secure for. In what contexts is it secure? So, what are your users' mental models? Seek to understand their models of your application, of your product, of your organization, and speak to that model rather than the detailed technical ins and outs of what you know. All right, we're on the home stretch. Here are some takeaways that I hope you take away with you. Cross-pollination between security and design is really rare, and it's a huge missed opportunity. Our jobs, all of our jobs, are about outcomes rather than the usual patterns of, I am a designer, I color in, I'm a security expert, I tell you no. Funny because it's true. And always remember to align your goals with the end user's goals. And we can do this by aiming to know their intent. We can do this by collaborating with design and thinking about paths of least resistance. We can do this by understanding their mental models versus our mental models. And we can communicate to that model. Before I run off, I have one final anecdote to share. On one of the floors of our old building, right next to the door, there's this little light switch, and no one knows what this light switch does. But it's got a post-it note over it that just says, no. Can you guess what the first thing I did was? Remember, build rivers, not walls. Thank you. Oh, yeah. Does anyone... There was very little heckling, which I'm a bit disappointed. Just anyone yell out. Oh.
What did the switch do?
I don't know. But I flicked it on and off quite a few times, so like somewhere, I'm sure like someone in an office floor, like on another floor, is just working focus mode and suddenly, yeah.
Hi. What would you suggest we should put instead of that lock icon? Any suggestions from a design point of view for secure websites or whatever? Like
Right,
just
so,
to show encryption.
Yeah, so Google is on their way to doing the right thing, which is no lock icon at all. So when things are going good, when things are expected, when everything is encrypted and working as it should be, security should be invisible. So, and that's what Google are doing. They're moving towards a design. Right now, there's a lock, no green lock, nothing that says secure. But they're moving towards a design where you just show the URL, and that's it.
It's not secure, which is a false,
Right. So that's the thing, is that ideally what you want to do is kind of raise the alarm when something is wrong. So yeah, say not secure when something is unexpected, but that becomes really tricky because then you run into false alarm effects. So the thing to do would be to try and communicate the correct level of alarm that you want to raise. So if something is unencrypted, but there's heaps of websites that are unencrypted all the time, then maybe a lower level of alarm would be good. If we're moving, and hopefully we are moving towards a world where everything is just encrypted by default, and something then unencrypted comes along, then it's reasonable to raise the alarm. But
That doesn't solve the
yeah.
phishing problem, though, right?
No. But that,
Or isn't the question more directed towards that?
and overall, well, that's a tricky thing, right? Is that there's no like. Yeah, and this is kind of like it gets into a different discussion where it's like, how much of this authentication process can we automate? Because we don't want to rely on people to check URLs. No one's going to do that. No one has time for that. And this is where things like the YubiKey is really, really good, because the whole reason why a YubiKey is like unphishable is that it doesn't require humans to check URLs, because it stores the URL on the thingamabob. So you kind of want something like that, where it's like you don't need to count on a human to do things that humans aren't good at, which is like boring tasks and checking things. We suck at that. So yeah, I guess it's a harder solution to implement, because then you have to like get everyone on board and like, but hopefully we are moving slowly towards a world that does something like that. Sorry. Oh yeah.
Thank you for your preso. It's really insightful and really excellent. Thank you. It's been brilliant. But the premise of a lot of your presentation is around user interaction. Whereas, for example, over the weekend, there was a vulnerability disclosed in all the Marvel firmware, which is on Chromebooks and Microsoft Surfaces and a lot of other devices that require zero interaction at all. It's wireless, you just send a packet, you execute code on the device, and now you've compromised that device. How do you communicate to users that these kinds of vulnerabilities are very serious, they exist on the device that they own, and that it has a personal impact to them without any user interaction? How can you communicate to a user, in your opinion, that this is a very serious problem, that they're personally affected, and it requires no interaction? There's nothing they can do until the patch is released.
Yeah, that's kind of tricky, because whenever you want to be reaching out to people in such a way to say, hey, something really bad's gone on, you want to be able to provide them with, and here's what you do. But if there's nothing to do about it, ideally, when you're in a situation where there's a lot of technical stuff going on in the background, and it's really hard to communicate those technical things to everyday people, you really want to, again, automate that kind of stuff away. So a good example is like automatic updates that just happen in the background, and you shouldn't have to worry about it. I don't know much about this vulnerability that's just come out, and this is kind of like the job of whatever copywriter is writing that kind of communication outwards as well, is to really front-foot it as like a value-driven kind of message, like, hey, you want to update because then, you know, this will make your machine better, kind of thing. But yeah, in our case, I guess the best that we can do is think about the bits of the stack or bits of the organizations that we're in that we touch. And sorry, this is not a very good answer. Yeah. And the thing is that when you think about the end user, there's actually heaps of end users down the line, right? So depending on like where you sit in an organization, the end user might be your manager, the end user might be some stakeholders that you're trying to communicate to. But the thing to always keep in your mind is the actual end user, which is like a random person, number 5, who sits down at the computer and uses whatever you make. Sorry, that wasn't a
So one of the things that interests me is, you make the comment about, focusing on the end user and your security thing with that. What you also need to remember is a lot of developers are actually starting out in the industry and don't necessarily have all of this thing. So one of the thoughts that I have is, how we say that security is at the end of the chain because they're the guys that say no. In the new kind of DevOps model, one of the theories that I have is that you need to have those security guys up the front.
Yeah.
So within DevOps, part of the thing is testing. People think testing is not necessarily a useful thing, but of course the DevOps is the testing is key. So get your security guys up the front, and if they can't provide a unit test, then tell them to go away and provide a unit test. Otherwise, they're not really contributing to the solution. They're still part of the problem.
Yeah, that's a good one. And like something that is a good challenge for me and also for everyone is if you think about like an area of software engineering or tech in general that you don't understand, and you find someone friendly to sit next to and you just sit next to them, that can be really helpful too. And I find that like the solutions for a lot of tricky problems like this end up always being the same, which is just talk to people that you work with, talk to people that you should be working with peripherally around you in your company, talk to people that have no idea about tech and need to like call you up to fix the printer kind of thing. Talk to everyone and just really understand where everyone's coming from. And it's hard work, but it's worth it. Yeah.
Thank you, Serena. My name's Martin. I only have 10 minutes this afternoon when I talk about digital identity. So if you could answer the following question, I could save some time. You correctly mentioned, thank you for your talk and mentioning the absolute inusable OpenGPG and also the let's get rid of that lock icon because it actually just talks about a trust relationship that is not grounded in your own trust. Have you thought about how we can, from a UI perspective, from a usability perspective, make people want to engage with this question, who do I trust? Because I feel that is core to the entire security conversation that we're having.
And do you think people are not engaged in that right now?
There's a list. Your browser comes with a list of CAs installed that somebody curated.
Yeah.
You have no idea about those.
Yeah.
You don't even know what those people out there, they don't even know what Let's Encrypt is. When that lock icon pops up, they have no idea what that means. When it doesn't pop up, or when it pops up as no lock, they have no idea what that means. And the browser has no way of finding out whether it should show this is not a secure icon right now, because it doesn't know who you trust. And there's no usability, there's no UI for this that I know that works.
Yeah. And it's kind of, and the thing that we kind of have to remind ourselves with, especially like this being a more open source community, everyone here is very hands-on with the tech, everyone here cares about it all, and we all believe that like everyone has the right to make their own choices in like which parties to trust. And that's really good. And I think something that we kind of have to remind ourselves a lot is that your everyday person with a job to do, they don't have time to make that kind of informed consent. And this is touching on, I think, a bigger, more generic problem in, like, even voting and elections. And it's like you want to get everyone to care, you want to get everyone to make an informed choice, but no one has time to care. And it's really, really difficult to actually make that informed choice, to inform yourself enough so that you can then make a choice out of it. So I'm sorry I can't. You're going to have to do your talk, dude.
Serena.
Yeah.
Thank you for the talk. I'm Nicholas. Very refreshing. You were focusing on the end user, the general public. What about you? Mm-hmm. We are a year after Meldon and Spectre. Meldon and Spectre, the hardware vulnerabilities.
Right, yeah.
Following a little bit what Marco and Martin said, who do you trust when you are dealing with hardware coming from where? And not necessarily the big iron, but IoT stuff. How do you feel?
This is going to be depressing. I mean,
Security, yay!
yeah. Well, okay. Yeah. Well, the thing is that it's like, how do you defend against supply chain attacks in our world of today, where our supply chain is like literally from everywhere? Can you get hardware that's not made in Shenzhen? Oh, you can. You can. Exactly. Yeah.
So my open question is, how do you feel? I understand.
Bad, man. I feel bad about it. Yeah, well, it's one of those cases where it's like we try and do the best we can. And in the case of like nation-state actors, if you have to worry about nation-state actors, I'm sorry, I can't help you.
I think I'm sorry I can't help you is probably a perfect way to finish the talk. Thank you so much, Serena. Big round.